Hi, everyone. Thank you so much for being here. So we are now in for a very interesting session. It's called Depend on Docker. Imagine a world where the only dependency you need is Docker. We have Alex. I will try and pronounce your last name. Iankoulski. Almost there. He's the principal software architect for data science and analytics at Baker Hughes, which is a GE digital company. And he's also a Docker alumni, and he's been a regular attendee since 2015. And we have Arun Subramaniyan. He leads the global data science analytics team at Baker Hughes Digital as well. Um, the floor is yours.
Everyone for being here today. Can you hear me okay? Yeah, okay, perfect. So, so we just wanted to start off with a little bit of context about why we are here and why we really got into using Docker. And we wanted to start the talk with some of the problems that we really care about. You may have heard of the company called GE. We are Baker Hughes, a GE company. We are part of GE as well. Some of the problems that we deal with on a daily basis. Every 2 seconds, an aircraft takes off somewhere in the world powered by a GE engine. Every day, 24/7, 365 days a year. 30% of the world's power is generated by a GE turbine of one kind or the other. Right. Just the scale of operations that we deal with. Now, Baker Hughes GE as a company was started about a year ago by combining GE Oil and Gas with Baker Hughes, two companies that in their own right were pretty big, as the world's first full-stream oil and gas company. What that means is it's the only company in the world which can explore for oil, extract oil, transport oil, refine oil, and give you the oil for power, petroleum, and all of different things. That's massive scale. There are very, very, very few companies in the world who can do that. And to do all of those things at scale and making sure that the aircrafts are taking off and landing on time and safely, power is generated reliably, we have to constantly build many, many models, thousands of models on a daily basis, which actually support our mission-critical products. And these models are fairly sophisticated. These are not simple models where I'm trying to predict who's going to click on what button next. It's actually predicting which engine I need to pull from an aircraft in the next time it gets into an airport, or which offshore oil rig do I need to shut down and impact 1 million barrels of production a day because a particular safety issue is going to happen. So very, very high consequence events that are happening, right? So we do build a lot of these models for mission-critical systems. And the raw material that we need to build models are data, of course. And data is really nothing new for most of the people in the room. And with all the buzz and hype about big data and analytics in the world today, it's easy to think that that problem has been solved, right? Now, if you look at the enterprise systems of the last 20 years or 30 years, compare that to the industrial world. The volume of data that the industrial world has to deal with and the velocity at which the data comes in that the industrial world has to deal with is anywhere from 10 to 1,000 times larger than anything that the consumer world can imagine. So imagine a jet engine taking off from New York and landing in London. It roughly generates about half a terabyte of data. An offshore oil rig generates data from about 14,000 sensors every 2 seconds being stored for the last 30 years. So some of the examples that you see here on the chart are just oil and gas specific, where from upstream that is extracting oil, midstream that is transporting oil, downstream that is refining oil. Just look at the volume of the data sets there. Some of them are per second, some of them are per minute, some of them are per day. They dwarf anything that you can see in the consumer world or in the ERP world. The problem is almost all of these today stay in their own silos. They don't really talk to each other. To get to even a simple answer about who did a maintenance on a particular piece of equipment, we had to go query 16 different databases. Many of them may not even be online. Right? So there's a data silo problem that we had to deal with. And to make problems worse, we have engineers and scientists who like to write software in their own way. So almost all of the analytics that we have to deal with are non-monolithic. They're extremely heterogeneous, meaning we have codes that have been in production since the 70s. We have very hardened pieces of code that's written in Fortran 77, God forbid Fortran 4, all the way up to the new kids writing code in Go or Python or anything like that. Right? And it's not like these codes, different pieces of code have to run individually, independently. They actually have to run together in the same orchestrated layer. And that's what makes it very, very hard. And when we started with Docker, the biggest problem that we were facing was, how do you manage dependency? The constant struggle we used to run into was somebody says, I built a model, it works on my laptop, it works on my desktop, it works in my own little station in my workstation. Now it's your problem to go and make it into production, right? Constantly. And the number of midnights we had to spend figuring out, hey, why did it work just half an hour ago, and why is it breaking now? Because something changed somewhere, right? Docker really saved us, because we could then say, you can write your code in whatever language you want, have whatever dependency you have, just make sure that the container works. Give us a container that works, and we'll make sure that it runs in production. That's really where most of our journey started, and you'll see the culmination of all of those efforts in terms of scaling. So just to give you an example, before Docker, and this was 2014, so before we discovered Docker, let me say it that way. To go from a developer, in this case an analytics developer, developing a piece of code, giving it to a whole bunch of their peers to test it out, to finally making it into production. And for us, production would be maybe 300 engineers who know exactly what they're doing to actually deal with that code. To then scaling it to an entire company would be a 6 to 12-month effort. And this is notwithstanding all the technical verifications that had to go through to make sure that this software is really doing what it's supposed to be doing. This is purely just scaling the software only. We went from there to using Docker and giving everybody an environment where they can develop inside a container that is already a minified version of our production system. And then take that into the production system. We went from 6 to 12 months to roughly about a year to an hour today. Right? And that is not just purely because of Docker, but it is the cultural and organizational transformation that it brought about in our own organization that enabled the developers to think, it's not really okay for me to develop something just in my own C drive or just in my own home drive. Let me develop inside the container that the entire organization uses. And let me add on to that container whatever I need to, and then ship my containers around. And that's really what brought on the speed increase. Right? And if you look at how long it used to take us to actually onboard a new person, they'll come in, they'll first of all need to get set up with all our proxies. That is, we actually have a hashtag proxy issue. Anything that goes wrong, the first problem is proxy. But then after that, it's all the other dependencies that we have to install. 1 week is actually being very generous. We've had cases where it's been a month and the person is not yet completely set up. Right. From there, today, we actually have people set up completely. If they know Docker already, it's 10 minutes. They do a Docker pull and they're done. Everything they need to develop, everything they need to push, everything they need to actually make sure that they're in our CI/CD systems are all done for them, including the credentials they need to make sure that they're pushing into the right systems. Right? And we were able to develop the tooling primarily because everything for us from development all the way up to delivery is containerized. Right? And we went from quarterly painful releases to continuous releases mainly because of that. And today, folks in my team who are all analytics developers, they're not really hardcore software developers, own production code that they write for analytics. Gone are the days when somebody else writes an analytic, passes it on to a software developer, and then the software developer actually has to maintain that in production. If something breaks in production for an analytic, the person who actually wrote the analytic is responsible for it today. The only reason that's possible is because of containers. Right? So we'll show you some stuff today in terms of how we've come about doing this, and also introduce you to some of the tools that we've developed, and also hopefully give it back to the community in the hope that you can also get the same speed ups that we've gotten. So I'll hand it over to Alex.
Thank you, Arun. Wow. Hello, Dr. Khan. I am really excited to be here because I feel like I've been preparing for this talk for 3 years. Today I want to share my story from both a personal and professional perspective, from both cultural and technical perspective. In my talk, I like to use metaphors and analogies. And I invite you to keep an open mind, and hopefully some of the examples I show will make you smile, maybe they'll make you think, and hopefully they'll inspire you to build great things with Docker. For me, the story begins with DockerCon 2015. I was one of the 2,000 people that attended the conference this year and listened to Solomon Hykes talk about the billions of creative people in the world and this incredible technology that exists and the gap that is between them, and how Docker was in the business of building tools of mass innovation that connect the people to the technology and make it so easy and accessible. We saw the explosive growth that the company experienced, not by hiring more people, but by affecting the community in such a profound way. We saw the Docker container pools from Docker registry go from 1 billion to 5 billion to 12 billion to 37 billion, and as it was announced yesterday, 50 billion with a B. That's amazing. I had the privilege of attending the talk that Jessie Frazell gave on container hacks and fun images, and she showed how she ran things in Docker that I had never even thought of. She ran her Skype in Docker, her browser in Docker, Visual Studio in Docker. Amazing. From that moment on, I've wanted to run everything in Docker. So, why we like containers so much? There are so many reasons, but one of the important reasons is that they make it really easy and accessible to break down monolith applications. I really like what the back of my shirt says: a container a day keeps the monolith away. But why do we like microservice architecture so much?
To illustrate this, I want to give you an example from my favorite movie, Big Hero 6. Ever since I saw this movie with my daughter, I've wanted to talk about it at DockerCon. The movie starts with a scene where these two robots fight. Now, if you had to take a gamble and bet your money on which bot wins, what would you pick? My mind tells me to bet on the big, scary, destroyer, monolithic robot. Unfortunately, if I go with that, I would lose my bet. As the fight heats up, we find out that the little harmless-looking robot is built by small autonomous components which can come apart and combine together in different ways to perform actions that no one could see coming, including disassembling the monolith.
So, needless to say, microservice architectures win. And there are these moments where we get to a fork in the road, and our choice was to depend on Docker. Choosing microservices, containers, allowed us to scale, to reduce complexity, isolate dependencies. And the more and more we use Docker, the more empowered we felt. And with this next example, I would really like to show you how building with containers makes us feel.
By the way, while putting together this part of the presentation, I had the privilege of getting in touch with producer Roy Conley and asked him, as the movie was being created, did you think of how these concepts could reach people far beyond your target audience? And he responded, at its best, our films work for kids ages 4 to 104. In this scene from Big Hero 6, the main character, Hiro Hamada, shows his microbots at an event similar to ours, where the boundaries of what is possible are being pushed. He controls thousands of microbots with a neurotransmitter, and that's the container orchestration I really want. Construction, transportation, the applications of his tech are limitless. If he can think of it, the microbots can do it. And we feel the same way about container technology.
If you can imagine it, you can build it. With Docker, the answer is always yes. The focus shifts from knowing how to build basic blocks to really needing to know what is out there. And that's why we say all you need to know is know what you need, know what to ask for. When you walk around the office, you start seeing how the culture has changed, and things you hear is, you're working on that problem? There's a container for that. I can't believe this just worked. So I want to share a quick story about a time when I was working on building a model that depended on a particular version of the MATLAB compiler runtime, and I was putting that in a container, having the hardest time figuring out all the settings, and just couldn't do it. I asked my colleagues for help, and collectively we just could not figure it out. And then I thought, well, maybe I should check Docker Hub. Surely enough, somebody had built a container that I could just run. I was so excited to find that out. I walked into my colleague's office and said, there is no spoon. So I have a reference to the clip from that movie. I'm referring to the movie The Matrix, where the main character learned how to bend the spoon by realizing that the spoon does not exist. From that moment on, every time, and this has turned out to be a pattern, every time we discover that we're solving a problem by realizing that the problem does not exist, we say, there is no spoon. So containers take us to the most unimaginable places, and I would like to share another story with you. It's a personal story, but I think it affects all of us today, to show you how containers take us to space. Recently, I visited the Johnson Space Center in Houston, Texas, and I saw the Space Shuttle Independence on top of the carrier and thought, what a sophisticated orchestration. I went into the shuttle, and by one of the illuminators, there is this poster of Dr. Story Musgrave, a distinguished, very formally educated astronaut. He has 7 degrees, who has flown on all of the space shuttles on missions. He is one of the people on the mission that repaired the Hubble Space Telescope. And I wrote to him about this talk. I said, I will be addressing an audience, and I know you're a really good speaker. Would you like to share some content with us? And he did. So what I'm showing today are pictures that he took on his missions and shared them with us today, along with some of his wisdom. You don't need to see the whole staircase, just take the first step. And the first step we're talking about here today, and the only step, is depend on Docker. Let's see how that translates to the technical aspect. I'll refer back to the talk Jessie Frizzell gave, and I really encourage you watch it if you have time. She showed a picture of how she containerized her closet. She organized everything in neat little containers, and it was looking great. That's not different from what we're doing here. On the right, you see the code flower of an open source project that we show as an example today. You can see how many dependencies and nodes are there in this graph. And what we're doing is breaking these dependency links, organizing them neatly in containers, and stacking them up to build our application. We believe that when you containerize your software, it's like putting it in a time box. It will live for a long time. You increase its lifespan because long after the operating systems have moved on. And that dependency that you have is no longer available for download from anywhere. And even you've forgotten how to run your software, you will remember Docker run. 10, 15, 20 years from now, it will still run the same way. So we use containers everywhere. And here are some of the use cases we have. We no longer install compilers. We have a container for that takes the source from source control, builds executable artifacts. We use Docker and Docker Compose to take those artifacts and build containers. And once we have our code in a container, we have choice. We can run the container on any operating system, Linux, Windows, Mac. We can run it on edge devices, on single hosts, on clusters of hosts. We can run it on CPU, on GPU. We could use different orchestrators, Docker Swarm, Docker Enterprise Edition, Kubernetes, Mesos. We can run it on-prem or on any cloud. And these are things that we have in the larger enterprise and that our customers have. And we cannot afford to say, if you want us to solve your problem, bring your data where we live or rewrite your code so we can run it in our platform. No. Docker gives us the choice to go to wherever the customer is and wherever the problem is. It allows us to scale up and down. That Will and Arun mentioned how we're able to compress the production environments into a microcosm and have the developer experience be no different than touching the production systems, except in a very nicely isolated way. Containers are used for so many other different use cases. We run Jenkins in Docker. They're perfect for software testing because you can stand up your environment, create the conditions you want, run the test, tear it down, very low cost. As you saw, we use it for development. We were really impressed with Docker technical support because they use containers to troubleshoot containers. They use containers to patch systems. I was talking to some people here at the conference, and they told me how they use containers to run their backups. And most amazingly, the people we work with at NVIDIA use containers to distribute firmware updates. So given all that, I see very little reason to be running anything outside of containers anymore. So today we want to talk about something we've been working on internally called Depend on Docker. Depend on Docker is really a philosophy that invites you to not install anything, but build a container instead. A project qualifies as a Depend on Docker project if the only thing it needs to go from source to running software is Docker. It's simple because you can create a new Depend on Docker project with a single command, and we'll see a demo of that. It's flexible because it runs out of the box, it comes with reasonable defaults, but allows you to customize anything you want about it, really. And it's universal because we've made it work on both Linux and Windows. One example of a Depend on Docker project is the Semantic Toolkit, which we saw the code flower of. It's an open source project that was started by GE Global Research, and the main contributors to the project are still there. But what I really want to highlight here is that we have the source tree, and there are a number of microservices here. They're Java Spring Boot. We have two scripts, compile.sh and compose.sh. Compile runs Maven in Docker and builds all of the artifacts, the executable artifacts here. Then we do compose build, it puts all of those artifacts in Docker, and then compose up -d brings everything up, and you end up with a fully running application. You can go check it out online, and you're welcome to contribute to it. It allows you to ingest data and analyze it semantically using, build Sparkle queries using a very nice graphical interface. This is a project that came to existence because of one of my colleagues who is in the room today. He really likes the command tree. Tree doesn't come installed by default on our operating systems. So the first thing he does when he gets on a server is install tree. And when he got on one of my servers, he wanted to install tree, and I said, no, we have Docker. And we really put together very quickly this dependent Docker project, which you run a container, it mounts the current working directory and shows you the tree. Now, you know how sometimes as you develop code, you have sensitive information that you need to store, but you don't have access to a really easy way to encrypt it. And you may opt for, oh, I'm going to base64 encode it and store it on disk. Or I'll just store it temporarily unencrypted and I'll come back to it later and fix it. You don't have to do that anymore, because we've built a dependent Docker project called Enigma. It allows you to easily encrypt and decrypt content. Here it shows how I ran the container to encrypt the phrase depend on Docker, and here I passed the encrypted string and it decrypted it for me. But that's not where it stops. I would really like to ask Arun to help us with a demo here to show you how easy it is.
I was beginning to wonder if I had anything to do, Alex.
So in this folder, Arun, I have put a couple of images, and they hold the answer to all of the problems that we have been struggling with.
Oh, wow. Okay. So is it in one of those images?
In both.
Let me try opening one of those. Secrets. Okay. Huh. What did you do? It seems...
Of course, it's a secret.
Aha.
So these images are encrypted.
Mm-hmm. So how do I decrypt it?
Well,
I know. There's a container for it.
Exactly.
Okay. So let me see. There is a file here that says decrypt file. Let's see if it works. And okay. Does it do? Ah, so it looks like it's running the Enigma container, and it's done. Let's see if it worked. It did. So there's one more file. Let me decrypt that as well. Okay. That's done as well. And I see you have another file that says show images. Should I just use that? Okay.
You can. Making things easy.
Uh-huh. There you go. There is no spoon. I must have guessed that. Okay. So although we are showing you a demo of an image being encrypted, really where we are using this is taking you back to where we started. So when we have multiple groups building models together, sometimes multiple companies building models, they don't necessarily want to share their IP, but the models have to talk to each other. So when we actually share models, the developers who are developing the models encrypt it very easily with the same commands. They don't necessarily need to know anything about encryption. They don't need to talk to anybody else. They just run one command, and the whole model is encrypted and it gets shipped out. Right? So the power of having tools like this enables us to scale very, very fast. So I'll invite Alex back here again to show you a full-blown demo of Depend on Docker as well.
Thank you, Arun. So to get started with Depend on Docker, I mentioned you really need to run one command. I'm going to show what's inside the create script here. I'll just copy and paste the command. Let me explain. This is the actual script. We're executing it with bash, and we're just telling it where to create our depend on Docker project. So when I run this, it goes out to our GitHub, and we have a new project created. It's as easy as that. The project structure is really generic, and this is a fully functional Docker container that you can build with the build script, ship with the pull and push, and run with the run script. These should be fairly self-explanatory. You can customize the project by editing the .env file. And here, I will just change the name of the image that I'm building to DockerCon. So in the container root folder, there are two scripts. The setup scripts, you put anything that you want run while your container image is being built. And in the startup script, you put anything that you want run when the container comes up. So since there's nothing here in the startup script, I'll write something real quick. Let's say we're just going to echo depend on Docker and sleep for a second in a loop. So let's build our container now. I'm running the build script. Container is done. Let's run it. Run script, done. Is it really running? Let's check with the status script. Oh yeah, it's up and running, but what is it doing? Well, let's see the logs. It's saying depend on Docker, depend on Docker. It's what it's expected to do. And it is as easy as that. We are going to stop our container and go back to the presentation. We have open sourced depend on Docker for this talk. It is on GitHub for you to use. We invite you to build your own depend on Docker projects and send us a link. We will be happy to include that link in the reference documentation for the project. And we will send you a sticker, a depend on Docker sticker, for contributing a link to our README. We are wondering what you're going to build next, so we are really excited. I want to take a moment to say thank you to all and everyone who has contributed or allowed us to share their content in this presentation. And to the audience, I'd like to say, I hope you leave this talk inspired to build anything you can imagine, and convinced that to do that, the only dependency you need is Docker.
And thank you so much. Thanks for